Thank you so much. Now I'm a bit relaxed. So yes, I'm going to present QGIS plugin we developed in the last 1 year. Most of the development was done in November of 2023 within a 1 month period, and then we published a paper which was just published this year in the Journal of Location-Based Services. Right. So Right, so a little bit about myself, just to give you an idea. I've spent a major share of my life in New Zealand and in the industry as well. So this is me going back to Fiji in 2023. Right, so how did I end up in geospatial data security? It started in 2004 when I was presented an opportunity to investigate encryption within the database for flat files. Major database management system vendors, Oracle and IBM, came up with a solution where flat files can be stored directly within the database, and it basically creates another drive on your system. Oracle Internet File System creates an O drive, and then my research was to create an encryption solution around that for flat files. Now that research helped me undertake this research at the University of Auckland in 2021, focusing a major focus was on indigenous data sovereignty, and what I'm going to present is a QGIS plugin which is based on the ideas from that project. Right, so in terms of geospatial data protection, one of the main criteria is to give the user main control of the dataset, main control of who has what access to the dataset, right? And this should not be decided by a third party. The person who is creating the dataset or data guardian, he or she should be able to decide at what detail who can access the dataset, who can access at what detail. Now, existing solutions to address this criteria are browser-based. There are two browser-based solutions: privy2.me, which is limited to only location sharing, individual location sharing, and then MapSafe.xyz, which was created by us 2-3 years ago. But the limitation is that not everyone will use browser-based solution. Another limitation is that a browser-based solution has limitations to how big of a file it can perform anonymization on and encryption upon. Right, so this is the MapSafe.xyz browser-based solution, and we realized that in terms of geoprivacy, if you are advocating for geoprivacy, then we do not expect everyone to integrate a browser-based solution as part of their workflows. So it might just not be usable. So what the next step was to focus on desktop-based solution to mirror the exact features on a desktop app. Right. So if we were to develop the same features, the requirements are catering various user trust levels. Different people within an organization can have different trust levels. We don't want to give access to the original locations to everyone, right? And then the original dataset we can encrypt, but how do we handle key exchange? If we use symmetric key encryption, how do we exchange that passphrase with another user? So, yeah. And then finally, verifying authenticity of the dataset. The QGIS gave us a very transparent platform and an extensible platform to deploy this kind of functionality. Right, so the main flow was if two sets of users, the encryption workflows, we want to safeguard the dataset, first anonymize, encrypt, and then notarize on the blockchain. We are notarizing the hash value of the encrypted file, so that anyone receiving that encrypted volume can first verify, recompute the hash value and verify the one stored on the blockchain, and then decrypt and access the dataset. So in this presentation, we are using a running example of Jane, who wants to safeguard the location of maybe newly found oil drill locations in Kamloops, Canada. She wants to share the original locations with her boss somewhere in the UK or in US. But she also wants to share anonymized versions with her co-workers just for logistic purposes, so that they can give at least some idea of where the locations are, so they could prepare for the next steps in their business. Right? So the first step, as I've explained, the first steps are anonymization, encryption of the original dataset, and then putting the hash value on the blockchain. The finally encrypted volume can be stored on Jane's computer or on the cloud. Okay? And then the person receiving the encrypted volume can first verify its originality by using the hash value, and then decrypt and then display the dataset. Right? The first step is, I'm showing screenshots from the QGIS plugin. So the first step, if you can see, there are 3 tabs in the plugin. First one is the safeguard, access, and the shield passphrase, which I'll explain later, is basically trying to encrypt the encryption key with a public key so that you can easily share. Now here, during anonymization, there's 2 options. The user can either perform geomasking, using donut geomasking, again the minimum and maximum, the buffer within which we want to transform the locations to, and then, or they can perform hexagonal binning. Now, in this particular scenario, there are 3 datasets that are 3 layers, 3 resulting layers. The red ones are the original, the light green ones are the masked version, the geo-anonymized, slightly anonymized, and the yellow ones are the more anonymized, means anonymized with higher values. So these options the user can choose from this the anonymization tab. Instead of anonymization, they can perform hexagonal binning. This is when you just want to share the density of locations. The density will be, and then again, the user can choose whether he or she wants to create 2 layers, 2 anonymized layers. Hexagon bin layer at resolution 7, and then additional layer value is added, and then it's hexabin at 2 levels. So for example, in this case, the resolution is chosen in 6, right? And then there is a hexabin layer created. If the user chooses, I want to create 2 hexabin layers, then the next one will be created at resolution 7. Right? So we have 3. In any scenario, we will have 3. Original, the slightly anonymized, and then the more anonymized. Right? So how do we, so we have 3 different detail levels. We have the original data set, and then anonymized at a certain detail, and more anonymized. How do we encrypt it? So to control access to this data set, we only have the final encrypted volume will be only a single file. It will be encrypted in a nested manner. We will have a 15 times passphrase that will be used to encrypt the original data set. From those 15 times, 10 times will be used to encrypt the middle layer, and 5 times to encrypt the outer layer. This is how the final encrypted volume will have the nested encryption. First encrypt the original, then the original encrypted file will have the middle layer, then it will be encrypted together, and then you'll form the final volume. So why are we doing this? This is basically to make it easy in terms of coordination. We didn't want to have 3 different encrypted volumes, just have 1. And then to control access to it, we just give 10 times of the passphrase, or 15 times, or 5 times. So with 15 times they can decrypt to the innermost layer. Right. So this is the encryption tab. The user can choose to include 1, 2, or 3 layers. Right. And based on the length of the passphrase, based on the number of times given for decryption, that's how we control access to the dataset. Right. So one of the main reasons why we wanted to supplement the browser-based MapSafe tool, supplementing it by allowing larger datasets to be masked and encrypted. So how does the desktop version compare to the browser-based version in terms of masking? Right. So these are the geomasking types, and it is 5,000. The masking is 5,000 points faster than the browser-based MapSafe tool. Right. It's 5,000 times faster. 5,000 more points are masked in a second compared to the browser-based solution. And if you're talking about encryption and decryption, it is about 100 times faster than the browser-based solution. Moreover, 1 gigabyte shapefile can be encrypted in 3 seconds. And that is infeasible with the browser-based solution. So we are using symmetric key encryption, but it becomes a challenge when we want to send the encryption key to another user for decryption. So easier way was to use another person's public key to encrypt the encryption key and then send it over. Right? And the person receiving the dataset can decrypt the encrypted encryption key with their private keys to get the symmetric encryption key for decryption. Right. So finally, the hash value of the encrypted file is notarized on the blockchain. So in this case, we use the Sepolia testnet, and once they press notarize, once it's minted on the blockchain, the URL address will be shown, and they can quickly see it. It being minted. Right. So the next step, the person receiving the dataset could use the blockchain address, the hash value minted, to verify it and then decrypt it. So here is the main control aspect. So if I want to give someone access, I can choose what level of access they want based on the number of passphrase I provide. So here the user can enter based on 5 times, 10 times, or 15 times, and that is based on that they will have access to the innermost layer with the original dataset or the anonymized versions. Right. So all of this, what I have said, it can be shown, can be summarized here, or the main idea is this screen. We are talking about control. So we have 3 different layers: the original, the slightly anonymized, and the more anonymized. So there will only be a single encrypted file, and based on what the person chooses, the original data owner chooses, they can only have access to a certain level based on the number of passphrases given, and I can choose that. I can choose to give someone 15 times, and they will have access to the original. I can choose to give them 10 times of the passphrase, and they can only have access to the middle layer, or they can have access to the more masked version. Right? So this is how it will play. If I give someone the alt 15 times, they can see the original. Either it was geomasked or it was hexabinned. If I give someone 10 times, they will see the middle layer, which is slightly anonymized. And then if I give someone 5 times, they will see a more anonymized version. Right, so we are talking about trusted users, semi-trusted, and untrusted users. Right, so finally, we extended the plugin to allow because not everyone will always want to use all three features. Some of them would come in with a requirement. We wanted to allow the plugin to handle scenarios where a user would just want to put a hash value of the dataset on the blockchain without needing to do masking, without needing to do encryption. So for that, the plugin is available in two modes: individual and combined mode. So this is a switch on top left of the plugin where that can be chosen, which basically allows the user to start with any mode and then proceed towards the right. So the user can basically upload a original dataset and go on to encryption directly, right? And save the file, save the encrypted file, and not having to do geomasking or notarization. But some users, there is a use case where some users need to be directed. You need to do anonymization, encryption, and notarization all in order. For them, the default mode for the plugin is combined mode. You need to do all three steps. That's the default mode. The reason is that to take advantage of the full workflow and create, ensure that users don't switch back and forth, go back after doing the second aspect, they don't go back. So we wanted to ensure they proceed in order, first, second, third. Right, so a little bit details about the plugin. As of it's been 18 months now, we have 3,000 downloads. The plugin has a website of its own which gives out all the details, instructions. It's released as open source, so the repository is on GitHub, and I can actually quickly show the plugin in action. Right, very quickly, less than a minute, I'll just show how it's done. So
the MapSafe QGIS geoprivacy plugin.
Right, so we are loading a shapefile. We're loading a shapefile.
Owners can invoke the plugin using the MapSafe icon. On the plugin's first use, the working directory and notarization parameters need to be set. The plugin can be used
right, so
mode.
This is
The data owner chooses these boundaries, as well as
this is basically the minimum and maximum distances, the buffer being selected by the user, and then the geomasking is performed. Once the geomasking is performed, 3 layers are being created. Instead of geomasking, the user can perform hexagonal binning of the original dataset. After that, the encryption will take place, where the user can choose all three layers, right? And then the hash value of the encrypted volume is minted on the blockchain. A URL, yes, so this is the Sepolia testnet where the hash value will be stored. You can see, right, so this is the file name and the hash value that is being stored on blockchain for verification later on, right? So when a user wants to access, so the encrypted file is loaded, so the hash value will be compared to that on the hash value will be compared to that on the blockchain. Right, so compare that. Once it's then, the user can proceed to decryption, choose the first 1, 2, or 3 levels, and then finally, yep, the dataset will be encrypted dataset will be decrypted based on how many times of the passphrase is given to that user. Right, so that's that. And right, so what has been our contributions? The contributions are basically, contribution is a desktop application which integrates into the GIS, existing GIS workflows, which can accommodate various trust levels, various user trust levels. At the same time, gives power to the original data creators, the guardians of the data set. Yeah, and then it complements our browser-based MapSafe XYZ tool by being able to mask and encrypt much larger data sets. It's open source and transparent. You can see the code. Anyone can see the code and build upon it. And then the next step is try to see if we can implement the same features in QField mobile app. And I'm very grateful to the QField developers who are here, and I've been working with them on Monday, Tuesday, probably, hopefully tomorrow and the day after, so we can see if we can extend the features into the mobile app. Right, so that was my presentation. Thank you so much.
Do we have any questions for questions?
Hi, I just want to see if I understood correctly that the data set that's being shared is static and read-only for the people that you're sharing with.
So what's
the data set that you might share, the original data set, is that a static data set and it's read-only for the people that you share with?
They can decrypt it and they can modify it.
So if they're modifying it, how do you handle multiple people that might modify simultaneously?
No, once a sensitive data set is being shared with people, and they can decrypt it and modify it and send it back to, share it with other people. But if you talk about coordination and modification of the data set, that will require multiple iterations of, again, encryption again.
Okay.
If they modify it, then they can encrypt it again and share.
So they share it back to let's say the original creator.
Yes.
And if the original creator has received two different sets of edits from two different people,
yes,
do they handle the conflict manually?
If there is a conflict, before encryption, they would have to resolve it somehow.
Okay.
And then proceed with geomasking and encryption. I mean, there could be a scenario where we can use version control systems, such as GeoNode. If you were here in the last, so after 1 year, the data set could be modified, the locations could be modified. So it will require re-encryption and then distribution again.
Okay.
Any more questions? No? Okay, thank you, Dr. Sharma.